Hello, I'm Lubo and this is my Lab 2 charge tape video lab report. The purpose of this lab, just like in Lab 1, is to observe the interaction between charged pieces of tape and determine their charge, this time using a more sophisticated computational model to do so, and the results of this lab summarized are that each charged piece of tape was estimated to have a charge of 1.886 times 10 to the negative 8 coulombs. The fundamental physics principles in this lab are Newton's first and second laws of motion, Coulomb's law, which states that the electric force between two interacting objects is directly proportional to their charges and inversely proportional to the square of the distance between them, and Coulomb's law for distributed charge, specifically of a charged rod, which is going to be used to represent the tapes in this particular investigation. A quick summary of the experimental procedure: two pieces of tape, tape A and tape B, are charged. Tape B is placed between two blocks, and then tape A is brought closer to tape B until the point where tape B starts floating. At this particular point, the electric repulsion from tape A equates to the gravitational force acting on tape B. The system in this particular experiment is the top tape, and the surroundings are the lower tape and all the other surroundings. Initial conditions are the same as the previous lab. The lengths of both tapes is 20 centimeters, their weights are 0.2 grams, and the distance between the wooden blocks is 14 centimeters. Some experimental assumptions that were made are that the only forces acting on the upper tape rested between the two blocks are the gravitational force acting on the weight and the repulsion from the tape below. Both pieces of tape were assumed to have the same charge. The electron density is the same between both tapes, and both tapes are treated as uniformly distributed charge rods. So looking at the experimental results, the separation between the tapes at force equilibrium was 0.015 meters. Using this information, we equated the gravitational force acting on the upper tape to the electrostatic repulsion from the lower tape, and we, in this case, used the distributed charge equation for the electric field. Continuing on, after finding the electric field from the lower tape using the distributed charge rod equation provided to us in class, we equate the electric force from the lower tape to the gravitational force acting on the upper tape, and we find that both pieces of tape have approximately a charge of 1.886 times 10 to the negative 8 coulombs. This is the glow script code for the initial system properties and conditions. The mass of each tape was 0.0002 kilograms. The length of each tape was 0.2 meters, and the separation at force equilibrium was 0.015 meters. These lines of code create a line charge to represent the tapes. This code here is used to calculate the electric field from the lower tape, and also the forces acting from the lower tape on the upper tape, as well as describing the gravitational force acting on the upper tape. And here is a visualization of the force equilibrium from the glow script code we just discussed. The white line is the electrostatic repulsion force from the lower tape, which is represented as the blue line below here, if you can see it. The yellow arrow is the gravitational force acting on the upper tape, and the green arrows here represent the electric field from the lower tape acting on the upper tape, which is the red tape right at the base of the electric field lines. To conclude, each tape was calculated to have around 2.7 times more charge in Lab 2 in comparison to the results from Lab 1. Possible source of error in this investigation are that the tape lengths could have been measured incorrectly, as well as the separation between the tapes at force equilibrium. Discharging of the tapes during handling could have skewed our results, and negligence of the reaction forces from the wooden blocks could have also caused a source of error. What if you had modeled each of your tapes as a single point charge like you did in the previous lab? The estimated charge per tape was 2.7 times smaller when the tapes were treated as point charges as opposed to distributed line charges as we did in this particular lab report. If we had modeled our tapes as point charges instead of line charges, then we would have gotten the same results as Lab 1. And finally, let's discuss why these estimates differ. The estimates from Lab 1 and 2 differ because the electric field exerted by a point charge and distributed line charge are completely different. Whereas a point charge will exert an electric field straight up towards the point charge, the distributed line charge electric field looks like the green arrow in the GlowScript visualization shown earlier in the slideshow. The reason for this difference is the disparity in distance dependence between both models. The estimation from Lab 2 of each tape having a charge of 1.886 times 10 to the negative 8 coulombs is likely the closer one to the real value, since in reality charge is spread out along the tape's length and is not concentrated at a single point. The distributed line charge model is hence the more accurate one to use.